Hey there, welcome back. How do you figure out some of these circle problems is what you might want to know. So I'm going to show you one real quick. If we're just meeting, my name's Mark Nolde. I teach high school math. I teach students how not to be intimidated by some of these math problems just by breaking them down into smaller chunks. So let's get into this one. So here was an interesting problem I gave recently on a PreCalc quiz. And it says, find equations for the circle, that's this red circle here, and the line in the figure. So this tangent line, this blue line, is what we're looking, I guess it's a segment technically, but we want to find the equation for that line. So step one. Let's find the equation of this circle. So the first thing I'll do is try to find the equation of the circle, and then the last thing I'll do is find the equation of the line. So the first thing I needed to know was that the standard form, let's see, my circle is red, so I'll write in red. So the standard form for a circle is x minus h squared plus y minus k squared, the quantity squared, is equal to the radius squared. So I do need to know what this radius is too. So my center, right here, if you'll notice, it's right on the origin. So the center is 0, 0. So if I just go about substituting x minus 0 squared plus y minus 0 squared equals r squared. I don't know what r squared is yet because I have to figure out the distance of this segment. So I have one of two ways to do this. Way number one is to use the distance formula and say, well, the radius is going to be equal to the difference in the x coordinates, 5 squared, plus the difference in the y coordinates squared. So that gives us, you see where this is going, don't you? 25 plus 144, which is 169, or 13. So this, let me use my pointer. So this was 13. What some students did, and it saved them a lot of work, was recognize that they had a Pythagorean triple here, right? They had a 5, 12, 13 triangle. So they instantly knew that this was 13 after looking at it. So over here, we'll do our 13 squared, since we now know what that is. So when I simplify it, it just becomes x squared plus y squared equals 169. So that takes care of the equation for the circle. The next thing we need to do is figure out the equation of this blue line that I was pointing at. Blue line right here. So we have already figured out the equation for the circle is x squared plus y squared equals 169. So the next thing I need to do is figure out what is the equation of this line. Well, I see that it's a tangent. It's marked with a right angle symbol here. So whatever this line is, its slope is the opposite reciprocal of this line. So when I look at my radius of my circle, I go down 12 and right, that doesn't look like a 12, and right 5. So the slope of this line is negative 12 fifths. So I want a slope for this line that is the opposite reciprocal of negative 12 fifths. So let me switch to blue because the line is blue. my slope of the perpendicular line is positive 5/12. That's a pretty bad 5. It is positive 5/12. So now we know a point on this line, negative 5/12, and the slope of the line. So I'm going to make haste in using the point slope formula, which is this. So y minus 12, right? That's my 12 from up here. Y minus 12 equals, well, we just figured out that the slope was 5/12, so equals 5/12 times x minus, well, let's see, minus a negative 5. So minus a negative 5. So that's a line right there. I could leave this just like this. A lot of students want it to be in y equals mx plus b form, even though it's not called for here. But it's good practice, so let's go ahead and do that. So y minus 12 equals 5/12 times x plus, let's see, 25/12. Because 5 times 5, right? And plus minus times minus is plus. And then I have to add this 12 on both sides. So remember, a 12 is 144/12. So I'm going to add 144/12, giving me 5/12 times x. 144 plus 25 is 169/12. So if a person insisted on putting it in slope intercept form, this would be it. Although this is just fine. This is the equation of a line. This line and this line are equivalent lines. So either one, since we're not told in the directions which way to do it. So I hope that was helpful for you, but I like those multi-step problems. Sometimes once somebody sees it done, the next time you see one, you are all about it. You're very good at solving stuff you've seen done before. Okay, so thank you for watching to the end. I hope you got some value out of that. Circles and lines can be a very tricky part of pre-calculus. But just remember, none of this is a spectator sport. I always tell my students, math is not a spectator sport. You have to do the work, you have to put in the time, and most importantly, don't ever give up. So hopefully you like this. If you did, give the like button a smash and subscribe if you will. Thank you very much, and until the next time, Noldy out.